Okay, class, here is a solution, or here's a problem that is very unique because it holds two perfect squares, and I hope you notice that here. 16 is a perfect square of 4, 81 is a perfect square of 9, and n squared is a perfect square of n. So 81n squared, if I take the square root of that, I'm going to get 9 for the number part of it. I'm going to get n for this part of it. Okay, square root of 16 is 4. And when you have a perfect square minus another perfect square, we need to understand that this factors into the squares, the plus in between them on one side, and the squares or the minus in between them on the other side. Now, if you don't know what I mean by that, you're going to have the perfect square root minus the perfect square root, and then the other factor in your factoring here is going to be the perfect square root plus the perfect square root. Notice the signs are different. Here's why it works, folks. If I just look at this times this, that's a minus 36 times n. If I look at the outside terms, plus 4 times a plus 9, that's a plus 36n. Minus 36n plus 36n, that cancels. They go away. So all I'm left with is the 9n times itself, which is 81n squared, and then the 4 and the 4, which is 16 squared. But look, it's a plus and a minus. A positive times negative is a minus 16, and that's exactly what you started with. Okay, so my writing here is not very good, but really, that's not the solution. I'm just trying to show you why that works, okay? So understand that this is our factoring here. I'll change colors. Oops, I'll change colors here if it works. Okay, but just remember this is our factored solution here from the beginning. Okay, now back to business here. 9n plus 4 times 9n minus 4. Now I might have written them in different order, but it doesn't really matter. Okay, it's going to come out with a plus between this perfect square roots and the minus between the perfect square roots. That's an n. Okay, now I'm just trying to solve each of these. If either one of these equals 0, doesn't matter what the other one is, 0 times anything is 0. So this is a solution. 9n plus 4 equals 0. I solve it, find where this equals 0. So that's equals 0. 0 times anything is 0. Now I'm going to find one solution. 9n equals, move the 4 over, minus 4, and I'm going to get n equals minus 4/9. Can I reduce that fraction? I don't think so, right? Even number, odd number, 3 goes into that, 2 goes into that, but nothing goes into both the 4 and the 9, so that's one solution. Now, in similar fashion, I set this one equal to 0 for the same reason. If what's in this bracket here equals 0, it doesn't matter what's in this bracket over here. If this is 0, 0 times anything is 0. Therefore, what's in this bracket equals 0 is a solution. 9n equals 4. N equals 4 divided by 9. Okay, so I wrote it a little bit differently. Maybe I'll fix that. N equals 4/9 if it looks better like this, and there's my two solutions. Once again, your book might write this as minus 4/9 plus 4/9. And again, this makes it look like an ordered pair. That's why I'm not fond of this way of presenting the solution. Your solution is n equals 4/9, n equals minus 4/9. This is not an ordered pair. This is just showing you the two x values that give you a solution.